In this video, we will be discussing ionic compounds and how to name them. Ionic compounds consist of both positive and negative ions. That has to do with whether or not the atom had gained or lost electrons when it reacted. Here's a mock of the periodic table. Remember, everything wants to be like a noble gas, and the atoms are going to either gain or lose electrons to be like that. On this side of the periodic table, they tend to gain electrons because it's easier. That's meaning that they're gaining a negative charge, which is making their final charge negative. On this side of the periodic table, they tend to lose electrons, making them positives because they're losing the negative charge. And two negatives equal a positive. This side are metals, and these up here are nonmetals. We discussed this in the previous sections. This interaction that they have between the positive and negative is called ionic bonds. They tend to have very high melting points and solid at room temperature. Think about salt. Sodium chloride, table salt, is an ionic compound because sodium has a +1 charge, chlorine has a -1 charge. Those opposite charges being attracted is very, very strong, which is why it's really hard to melt salt. Unlike sugar, where if you put that on the stove, it will actually melt. So here once again is sodium chloride. Here's the sodium atoms, and then it loses an electron, and the chlorine atoms gain an electron, and when they come together, they produce this white crystalline. An ionic formula is something that shows these positive and negative charges. However, they are neutral because the positive and the negative cancel out. So their charges are balanced. The positive charge is equal to the negative charge. You always write the metal first. The positive always comes first. And then the negative. So for instance here, Mg, if we look on the periodic table, is right here. It has to lose 2 electrons to be like a noble gas. It's in the second row. That's how it got its +2 right there. Chlorine is right here. It had to gain 1 electron, so that makes it a -1. It's in the second to last row, and that's why it's that charge. We need 2 of the chlorines to balance out 1 of the magnesiums because those charges need to be balanced. They need to cancel each other out. So those subscripts that we're seeing here tell us how many we need of each. So that way the total charge is 0. So let's look at Na2S, the charge balance of that. Na is right here. It's in the row of +1. We have 2 of them, so we have 2 + 1 charges equals a +2. 2 times +1. S is right here. It's in a -2 row. So there's no subscript here, so it's 1. It's a -2 charge, so 1 times -2 is -2. Add those together equals 0. The +2 and -2 cancel out. And here we go. The +1, we have 2 of them right here. Both equal +1, and we have 1 -2. So that's going to cancel out. So if we're going to write the formula of something, for instance, Na+ and N3-, we need those charges to balance. So we have something times a +1 is equal to whatever, and something times a -3 is equal to whatever. If we have 3 + 1s, that comes out to be a +3. If we have 1 -3, that equals a -3. So that means we need 3 NAs and 1 N3 minus. There is a shortcut to this method, and I'm sure you want to know that. If you put those two letters together, those two elements together, with the charges there, if you crisscross over the anion and bring those numbers down, Na3 N1 sodium nitride. So we have 3 NAs and 1 N. That will automatically make sure that those charges are balanced, and that works 100% of the time. So for instance, Ba2 plus and Cl minus, if we put them right next to each other, remember the metal's written first. How do we know it's a metal? Look on the periodic table. Ba is right here. Here's the squiggly line. It's on the left of the squiggly line. That's how I knew it was a metal. Crisscross it. Ba, I drop the charges and only take the numbers. Ba1, Cl2 from here. So it's BaCl2. You can double check that. We have 1 Ba, which is a positive 2 charge. That equals positive 2. We have 2 Cl's, which is a negative 1 charge. That equals negative 2. Add them together, and that's 0. The charges are balanced. So let's take a look at these. We have Na plus O2 minus. Crisscross those. So it becomes Na2O1 or Na2O. Al3 plus Cl minus, crisscross those, becomes Al1 Cl3. Notice every single time I drop that negative sign. That negative doesn't exist. Or Al1 Cl3, Al Cl3, which is right here. And then finally, Mg2 plus and N3 minus, crisscross those, Mg3 N2, which is right here. We're going to stop there for writing out the balanced chemical formula. Next session we'll talk about how to name them.